well. So I don't, the fewer interruptions, and you guys paying attention and that kind of thing, the better. So you should have already done the exponential functions. I don't know why we didn't add it before. And then point slope form is going to be in our calculator active FRQ, so I'll remind you guys about that. It's just another way of writing an equation of a line. M is your slope, and x sub 1 and y sub 1 is a point. So if you have a point and a slope of a line, you can use that formula. Whereas slope-intercept form is slope and a y-intercept. Okay, they're both very similar. Just depends on what you're given. Okay. You do need to know formulas on this test. There's no wrap formulas if you got to the calculator portion, unless it was in the non-calculator. Was it? I don't remember actually at the moment, but there's not in the calculator. But you definitely need to know these formulas. And the big thing you should know is the difference between these two. And I'll be talking about that in some of the questions that I do. One thing I wanted to tell you, for some reason, in my key, I noticed it yesterday, you should not be talking, is I had number 10 on the non-calculator. I had that was a flip. It's a horizontal dilation. Flips are negatives. So if someone noticed that, I haven't had a chance to fix it on Canvas, so I just wanted to say that. I will fix it before the end of the day, but number 10, that 3 is a horizontal dilation by a factor of 1/3, and I wrote the word flip right there for some reason. I don't know where that came from. So I just wanted to say that. I also don't remember what period yesterday I said that you guys could use these. I will let you guys use the basic 4-function calculators tomorrow on the non-calculator portion. So when you come in, put your phone up, leave the yellow calculator, and I'll have the little blue one sitting there ready for you, okay? All right, so if anybody didn't write the formulas down and needs to still, when I'm done, if you want to grab this and look at it, you can, but I'd rather you stay with me right now. What I'm going to do is both FRQs and the calculator active multiple choice questions, okay? So let's do this one, which I think this is going to be a really, really easy FRQ for most of you guys. So this is on your test tomorrow, okay, the no calculator portion. So it first starts out by asking for limit notation. And of course, you'll have a full-size piece of paper, so you won't have to worry about, so you won't have to squeeze it in. But for now, we can just squeeze it in. All right, so guys, writing your limit notation properly at this point is how you're going to get full credit. So limit of h of x, find the name of the equation, whatever it is. And it doesn't matter if you do negative infinity or positive infinity first. That's up to you. It's up to me to grade it correctly and notice which one you did put first. Right? So left and right. So looking at the table of values, as our x's approach negative infinity, right? The numbers are getting smaller to the left here. There's a weird symbol. That's negative infinity. What are our y values approaching? What are those numbers getting closer and closer to? Also negative infinity, right? Quite quickly, the numbers are jumping and getting smaller and smaller and smaller. So as x goes towards negative infinity, so does y. As x goes towards positive infinity, right to the right, what are your y values approaching? 4. And I use that analogy of like you guys being in the hallway in the concourse and like someone 5 groups ahead of you stops suddenly and you all kind of like jam up. That's kind of what's happening here. The numbers are getting closer together because they don't have as much room. Like over here, they're just going towards negative infinity as fast as they and quickly and whatever as they want. But here, there's something there that's not letting them go. It's trying to get to 4, right? But it's jammed up right there. That's a sign of an asymptote, okay? Domain and range. I always like to save domain and range until I draw the picture. You do you, but I'm going to come back to that in a second. Horizontal asymptote, you do not need to explain your reasoning, and I forgot to cross that out on the test, so it says it there. You just answer it the same way we are here. We have a horizontal asymptote at y equals 4. Not 4, y equals 4, right? Hey. Sketching the graph using label the y-intercept and the horizontal asymptote. Y-intercept is the y value and x is 0, right? So at 2.5, well, let's call you 2.5. That looks good. And horizontal asymptote at y equals 4. And then as my x's go to the left, they're going down, and as they go to the right, they're approaching positive 4. So, good enough. That's the sketch. And domain and range. The domain is all real numbers, guys. There's nothing blocking you on the right or the left from going and going and going, right? There's no vertical asymptote. There's no wall saying you can't go right or left. So that's from negative infinity to infinity. Not all real numbers. We want to really start getting in the habit of using interval notation on FRQs because that's what you'll be required to do next summer, May, whatever. And then range would be from negative infinity up until we get to 4, but of course not including 4, right? So we would definitely have to use parentheses on the 4. You would never put brackets on a asymptote, okay? So I think that's a really good FRQ that you all can be real solid with, right? Then on Thursday, you will start here. So, you know, I'm making a video of me doing this. If you know, I didn't catch exactly how she did number 6, or that one I'm worried about, you can go back and watch just that question if you want to. And of course, anybody that's absent, we're going to tell them they should watch this. All right, so find the ratio in the a sub 0 term, then write the general rule. We had a problem like this in our homework or notes once, and I didn't like the wording. General usually means explicit formula, and the big difference between the geometric sequence formula, which is our explicit formula, right, to find the nth term, and exponential functions is one has subtraction in the exponent and one doesn't. Also, exponential function always uses a sub 0 right here, always, never anything else, whereas you can use anything here. You could use the 0th term, the 6th term, any term here, okay, and you would just match it up with whatever the k is right there. All right, so the fact that they use the word general rule bothers me, but they did give me a model for my equation, and they're asking us very specific things to find. Find the r and the a sub 0. Now, they called r, what's really b, but r and b are the same thing. So you got to get over all the language. Bottom line is, it wants our equation to be in this form. So, guys, just right there, these two go away. They're gone. They're not in the right form. One has a negative n, one has an n minus 1. Just being a smart test taker and letting the multiple choices work for you can sometimes help you at least have a 50-50 shot, because you don't have to show work on any multiple choice anymore. Okay, so we need a sub 0, and we need r. Okay, well, r is pretty easy, right? I can see what I'm multiplying by, plus this is a calculator active problem. You could do negative 6 divided by negative 2 to see what it is. We are multiplying by 3. Did I need to waste my time on that for this problem? No, both of them have an r of 3, okay? But if they were different, that's what I would have done. Now, the only difference here is whatever the a sub 0 is. So I need to go backwards, right? If I'm multiplying by 3 going to the right, to go backwards, I would do negative 2 divided by that number, okay? So that would be negative 2/3. That would be this one, okay? And you all can trust me. You know, I've proven to you my word is truth. I don't change the order. You know number 1 is going to be this type of problem. If you're studying and trying and practicing and looking over this review, you should be fine, okay? The population of a bacteria colony can be modeled using a geometric sequence in an experiment. Assuming day 1 is the first day of the experiment, the population on day 4 is 5,000. On day 8, I have 52,000. Based on the experiment, what is the population of the colony on day 6? Okay, what I'm seeing there is a middle number. So, sake of me not writing it again. So, sorry. You have a sub 4, you have a sub 6, 8, and you're trying to find a sub 6. So in between there, of course, is 5 and 7. But what I hear is 6 is in the middle of 4 and 8. It doesn't have to be right in the middle. I mean, it is right in the middle, but you know what I mean. It doesn't have to be like you have these two and need this one. As long as it's a middle one, it can be you have the first and the 100th, and you can find the 50th or whatever it may be. That's geometric mean, and that's a formula you have to know. So you multiply 5,000 times 52,000, square root, and that would get you this number. Okay, geometric mean is used on geometric sequences only to find a middle. We'll get to the middle. Okay. Exponential model, given 2 points, that's using the stat function on your calculator. Okay, so you will always clear your RAM, go to stat, enter, and put in your lists. Pretty short list, right? We have 2 x values, 2 y values. You have to know how to put these in your calculator. Lists, stat, calc. I want exponential. You might as well just memorize it. The whole test, that's the only one we're using. It's 0. So you just hit 0, and it'll say at the top. And you technically don't have to store on this one, but we just want to be in the habit of doing it so we don't forget those steps. Alpha, trace, enter. So it doesn't hurt to store it. Okay? And there you can see your A and your B value. Good. I mean, how many times have we done that type of problem? A million. And it's on this test 3 times, doing those steps. Okay, number 4, exponential function f of x. Okay, there's the model, the equation, and they give us a table of values. Which of the following statements are true? So quick looking at those. Decay or growth, A is greater than 0 for all of them. B is either greater than 1 or less than 1. Okay, so let's look. Even though I have a calculator, I'm not wasting time with those fractions. It already told me this is an exponential function. So I can just say, what am I multiplying by here? That's times 2. Well, right away, I know my B value is 2, right? 10 times 2 is 20. Well, that's greater than 1. So that eliminates the 2 that have B is less than 1, right? B is 2. That is greater than 1. And what's the difference between choice A and choice B? Is one says growth, one says decay. Which one is it? Growth or decay? If you're greater than 1, you're growing. You're an increasing function. Less than 1, you're decreasing or decaying. Okay, suppose you drop a rubber ball from a height of 15 feet. We had a question just like this. On a hard surface, after the ball hits the floor, it rebounds to 80% of its height as its previous bounce. Sorry, how high will the ball rebound after its third bounce? Round your answer to the nearest 10. Okay, so the minute you see a percent sign, you know that this is either exponential or geometric. Okay, so this is either a B or an R. All right, and 15 feet. It's starting at 15 feet. That's before time has started, right? The ball has not bounced yet. It's being held in your hand 15 feet off the ground. So A sub 0 before time, initial height would be 15. B or R, whatever you want to call it, is going to come from that 80%. And this is where you have to decide if you're adding or subtracting it from 1, to 1, or from 1. And in this one, it's a little tricky because it's already saying it took 20% off, right? It's only going to go up to 80% of the previous height. So it's decreased the percentage by 20% already. So you are just going to change. Remember, you never plug in a raw percent. You always have to change it to a decimal. If you're worried that you're going to make a mistake doing that, this is on the calculator portion. All you have to do is do 80 divided by 100. It'll give you 0.8 or 0.8. And like we said, we're not going to add or subtract it. So guys, you really have a choice here. You could use geometric, you could use exponential. To me, exponential is easier. I'll show you both. But if I was going to use exponential, this would be y equals 15, 0.8 to the x, right? That's the equation of this. A sub 0 is always what you use in exponential. And guys, we want to plug in 3. Time is your input right here. So plug in a 3, and you would get an answer of D. If you use the geometric sequence formula, okay, that was like G of n equals whatever term you want to use, right? That's A sub k in this case, which is 0. And remember, this has the subtraction in it, n minus k. N minus 0 is what we would use, right? Because this is A sub 0 that we had. Well, look what happens when you plug in a 3. 3 minus 0 is 3. It ends up being the same equation. They're the same. Okay, so it really didn't matter which one you used. Okay. Denise earned this much money during her first year. Guys, that screams. That's your first term, right? That's how much she earned in her first year. As a blah, blah, blah. After each year, she received a 4% raise. I see percent. I know that this is going to be a B or an R or whatever. Okay? So B, R, whatever you want to call it, is 4%, right? Changed to a decimal. And then this, in this case, it's increasing. We would add it to 1. Okay? Oops, sorry. Decimal goes over there. 0.04. Sorry about that. So that'd be plus 1 is 1.04. Because think about it. You want 100% of what she made the year before and then another 4%. And then the next year, all of that she made the year before, 100% of that plus 4%. Right? And you can just create an equation, do whatever you want here, and solve it. So because they gave me A sub 1 instead of A sub 0, I don't think of this as exponential. I would use this one that has the subtraction in it, okay? Remember, exponential has to be A sub 0. It has to be, okay? So, that would be, and, you know, you don't have to show all this work. You could do a lot of this just right in your calculator. They want to know how much she's going to make in her 5th year. So I'm going to plug in 5 right there. Where did I get 1, guys? Where did that 1 come from? Yep, this is A sub 1, right? So my K value was 1. Just like I showed you when this was A sub 0, the K value was 0. Calculator work, you should be able to get that. It's money you round to 2 places, of course. So this went with this. Okay. So I look at this and my eyes glaze over. Okay, some word problem. Looks like I'm going to have to take some information and plug it into an exponential function. A times b to the x. Okay, what you got? Some company, distributed, blah, blah, blah. The value is expected to increase by 3.2%. If I didn't already know it, I would know now that this is exponential. Each quarter of a year at time, so time is our t value, and at 0 years, so at t sub 0, we had 37 million. Which of the following is an equation? Okay, so exponential, we need the first, or the 0th term, which we have. And all of them have it. Okay, that doesn't really help us, right? All of them have 37. Let's move on to the b value. B would be 0.032, right? Change your 3.2% to a decimal, 0.032, and it's increasing, so we would add 1 to it. So that'd be 1.032. Well, right there, you eliminate the first A and C. Now, here's where you'll get confused, including me, okay? This happened, they give you, whatever this is, sales, money, whatever. Whatever this is talking about happens every quarter, and there's 4 quarters in a year. So every year, how many times is your amount going to increase? How many times every year? 4. So is that 4 times t or t divided by 4? Times. And look, trying to mess this up by saying 1/4 of a year is your is what a quarter is, but every quarter in a year. So t equals 1. In 1 year, there are 4 quarters. 1 times 4. So 2 years, it'd be 8 times 3, and so on. Okay? So that's the answer. All right, half-life of morphine in bloodstream. So 3 hours, it takes 3 hours for morphine to come out of your blood, okay? And they have an equation that represents that. Thank you very much. We didn't have to come up with the equation. A sub 0 is the initial amount of morphine, and the patient at time equals 0. Okay, makes sense? And they gave it to us as, for this particular patient, that was given to us. Okay, so I can plug that in. M of t equals 0.4 half-life t over 3. Okay, what do you want to know? When will the morphine drop below 0.1? So what it's saying is we want to know what is the time, right? We want to know what the input is when the output is 0.01. So remember, one of the situations you can go to the table, one of the types of situations you have to use a special feature on your calculator, okay? This is, so the next one, which is nice, is using the table, or using the table. But when you need x and you have y, that's when you're going to use intersect, okay? And since we have equations, that's when we go up to y equals. So you're always going to clear your RAM, because remember, you stored something up there already, and you don't want to confuse your calculator, okay? So I'm just going to type in this equation, 0.4 parentheses 0.5 to the power of x over 3, okay? So all I did was type in the first equation. And we want to see what is x when y is 0.01. Just, we're going to put a horizontal line. And wherever they intersect is where what our x value is. Now, remember, intersection's the easiest of all of them, right? So here's what you would do on a multiple choice test. Look at your choices of x values. Your inputs are t or x, right? The smallest is 6 and the biggest is 40. What you want to do is go to your window and make sure your x max, in this case, covers all of those. Right now it only goes out to 10. If the answer is 6.72, we're good. But remember, we don't know on a test which one's our answer. So we just want to make sure we go out to at least 40. So 45, 50, I don't know, pick something. Okay? And here's what's really nice about intersection, guys. This is a really tight graph, even on my little fancy calculator. Where the heck is the intersection? The good news is it doesn't really matter, because with intersection, as long as you know it's somewhere on the screen, and it has to be, right? Our answer is somewhere in there, and we made sure it's those numbers are all covered here on the x-axis. Your calculator will find it for you. You never have to use your cursor, your like arrows, to find it. So we go to Calc, intersect is number 5, and you just hit enter 3 times. It will find it for you. Enter, 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 and you can see when y is 0.01, x is 15.97. Effortless, really, okay? You just have to remember to make your window cover all the x values. Then your calculator will find it for you. Don't worry. Okay? So we just typed equations in that we were given. Here we have a table of values, and we want to figure out, it even says the word regression. We want to do an exponential regression and then use that to figure out what 2.5 is. So we know what x is 2, what x is 3. What's 2.5? So the calculator will do that for us. We'll use our table. So again, we're in your RAM, and we have x's and y's. That's when we go to set. And you put your lists in. A little bit of a longer list, but I see how fast you guys text. Shouldn't take you too long. This is the third time. Oh, the second time. I think we still have one more time that we have to type all this stuff in. Stat, calc, 0, store it, alpha trace, enter, enter, enter. Now, we don't need the A and the B. Like, we don't need the equation. Don't waste time writing it down. We just want to know what is y when x is 2.5. Well, that's in your table. That's the table of values. But you guys know by now that the table defaults starting at 0, counting by ones. We want 2.5. So table set up the table is where you go. And just make it easy on yourself. Put 2.5 right there. It'll put 2.5 right at the top. And just go right back to your table. And when x is 2.5, y is 66.868. Okay. Being able to use all your calculator functions is a big part of this class. Like, that's why we require you to use these. You have to use it. You're being tested on, do I know how to put all this stuff in my calculator and give me the right answers. Okay? All right. 2 more multiple choice. Sales department, blah, 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 blah. A linear regression was used to develop a model for the sales over time. So the figure above shows the residuals. Okay? This is not a regression. This is not supposed to look like a line or anything like that. These are, remember the wrap formula? You do a whole bunch of wraps and you graph them and it makes some kind of a shape. And we judge the regression by the shape of the residual. We look at whether it has a pattern or not. Does this residual plot have a pattern? Yes, it does. That's bad. We don't want a pattern. So we know that the choice has to be either A or B, right? The linear model is not good because the residuals have a pattern. That's what I just said. It's not appropriate because there's a pattern, right? So it's either it has a pattern or not. Don't think too deeply on that. Okay? That should be a freebie. Last one before the FRQ. F of g of 2. Okay, let's see what we have. A table of values with g of x for g of x, and then an equation for f of x. And remember, we always work right to left. So we start with g of 2. So my input is 2 as the g function. So x is 2 right here. Y is negative 3. So g of 2 is negative 3. So now I have f of negative 3. Right? I replace g of 2 with what it equals. And now I plug negative 3 into the f function, f of negative 3. And you just put it in your calculator. 2 to the negative 3 plus, put that negative 3 in parentheses, squared. Type it in your calculator. You're going to get a decimal. Math, enter, enter. You should get that. So I'll give you a second to write that. Try it. Math, enter, enter. Changes a decimal to a fraction. Okay. While you're finishing that up, we're going to do the FRQ, and the very last question on this FRQ is where we're going to be using that point slope formula. And you haven't really learned it yet. It's easy, but you need to really make sure we pay attention. The rest of this is super easy. Okay, so on this FRQ, this is actually an FRQ from the 2024 AP exam that my students took that year. This is exactly what you'll see on FRQ2. Slight variations, but for the most part, exactly what we're going to do. And then there's a part C that we haven't learned yet, but this is, you're seeing something that you're going to see. And it talks about petitions online and blah, blah, blah. Bottom line is this. Scan the problem for time's sake. You should be able to find 2 ordered pairs in there. So we have time of 3, 4,000 signatures, time of 7, 23,000 signatures. So find your 2 ordered pairs. And when it's in thousands, you don't need to write it out like 4,000. You can just write 3, 4 and 7, 23. And then when you answer the questions, just use the word thousands in the answer. Okay? So somewhere in the word problem, you will find 2 points. Shouldn't be too hard. They give you the model. We're in exponentials right now. It's always going to be that on Thursday. It's going to be just like this, just a different scenario. Notice I didn't even read it. All right, use the given data to write 2 equations that can be used to find the values of A and B. Okay, so all I'm doing is plugging x and y twice into this equation, right? This is just y equals a times b to the x with fancy letters. So you literally just write y equals a times b to the x and y equals a times b to the x. That's the first thing. There's some points right there. Just knowing what it's asking, plugging in x and y. Part 2 is what is a and b? And this is calculator active. You guys know how to find a and b given points. That's that stat thing again. I told you it's on this test 3 different times. Here's the third one. Stat. Enter. 3 and 7 are your x's. 4 and 23 are your x's. Or your y's, sorry. So there's my 2 ordered pairs. Stat, calc, 0. Let's store it. Alpha trace. Enter, enter, enter. There's your A. There's your B. Always round to 3 decimal places. Right? That's a 9. Easy enough. B1 is asking for us to find, it sounds so fancy, use the given data to find the average rate of change in the number of signatures in thousands of signatures per day from blah, blah, blah. Guys, this is just asking for you to find the slope of these 2 points. Find the slope, okay? It does say to express your answer as a decimal and show the work, okay? It's exactly what it will say on Thursday and on May 12th. So I'm just going to do y's on top, x is on bottom. Be careful not to leave your answer like this. You do need to change it to a decimal on my test and the AP exam. Just trying to get you guys to make sure you read directions. Write it as a decimal. That's it. You all know how to find slope. So this, though, is in thousands. So the average rate of change from the 3rd day to the 7th day was 4.75 thousand signatures. So make sure you label it correctly. Okay, so that's going to give you full credit. B2, we're almost done. You're getting restless. Don't get restless yet because I've got to show you this new thing. What it's saying is use this slope that we just found to estimate the number of signatures when t is 13. They're giving us t is 13. They want to know how many signatures. What was it, S of t? That's what we're trying to find. We're going to use this slope in either one of these points and plug into point slope form. Guys, stay with me. I'm going to use the bigger point, but you can use either one. You'll get the same answer. So 723, this is going to be a point that I plug into point slope form. X sub 1, Y sub 1. That was given to us. Okay? The slope, we just found it, is 4.75. And don't forget, guys, t is an x value, right? It's your input. Here's that formula again. I'm going to give this to you on test day. I'll put it up for you just because I feel like, or I might just print it on your test since I kind of sprung it on you. And guys, this is the only variable we don't have. That's the only one we don't know, right? This y value, that's the one we don't know. So y minus 23 equals slope. Now careful here, the order matters. So if you were just writing in point slope form, this is what it would be. And now you can just plug any x value in to find y. So what x value am I plugging in? 13. That's what we want to know. What is y when x is 13? So this is just calculator work. 4.75 times 6, add 23, and you should get 51.5 thousand signatures. So what we're doing here, guys, is basically finding, so there's this, if I graphed it, if I graphed that exponential function, those 2 points, 3, 4, and 7, 23, wherever they are, we found the slope between those 2 points. What we just did was created a line, and then we used that line to make predictions, okay? So here's the line of that, right there, called a secant line. And now you can use it to find what? Okay, you want to know what might happen at t equals 13 days? We plugged 13 in and solved it and got our y value. Okay? So some fancy algebra there. Mm-hmm. Okay. So this part is Thursday.